In this lecture, we're going to cover section 1.5, which is equivalences, part 1. So what's an equivalence? So let's start with that. When we have two compound statements that are said to be logically equivalent, if they have the same truth values, regardless of the truth values of the variables involved. So what this means is if we have two compound statements and they have the same truth values, regardless of the truth values of the variables involved, they're logically equivalent. So for example, let's just look at the first equivalence, the double negation. So if I have P and we negate it twice, the value of not P, right, the double negation of P is going to be the same as P. So they're said to be logically equivalent. Now, why does that make sense? Well, look at the truth table. Let's say we compare P and not P, right? So here's P. P is either true or false. And if we negate P, right, then the true value becomes false, false becomes true. But now let's negate not P again, the negation of P, right? So not P. So we're negating the values that are in the second column, right? So false becomes true, true becomes false. And you'll notice that the truth values of P and not P are exactly the same. So we say that these two statements are logically equivalent, meaning they have the same truth values. And the symbol that we use, let me just point out the symbol because I don't want you to get it confused with the biconditional. So remember, if we have a double-headed arrow, this is the biconditional. That's what we use for the biconditional, right? But this fatter double-headed arrow, the thicker one, that just means equivalent. It's almost like an equal sign, like in algebra or math, right? But this is just saying, okay, these two statements are logically equivalent. So that's the symbol that we use, okay? So that is different, right? So if we have this versus this, right? So the thicker one, the fatter one is going to be an equivalence. So let's practice. Let's practice with this first equivalence. So let's just rewrite the following statements using the double negation equivalence. So in other words, for number 1, what is not C equivalent to, right? So there's our double negation. So not C is going to be equivalent to C. And we can negate something 10 times if we wanted to. So look at number 2. We have not P implies S. So this double negation, this not, right? Because look at what we're negating. We're negating the not P implies S, and then we're negating that statement. So that double negation is just going to make this equivalent to not P implies S. So whatever's in this set of parentheses, right? Because we have a double negation. And here we have not D, but we're negating that. And then we're going to negate that. So a not D is going to be D, right? The not D. But then we still are negating that. So we end up with not D. So a not D is equivalent to not D. And let's do one in words. So number 4 says, it is not true that pearls are not found in clams. So first, so typically whenever we're gonna use one of these equivalencies on a word statement, like a verbal statement rather than symbols, it's nice to follow 3 steps. Step 1, try to symbolize the given statement, and then apply whatever the equivalence is, still using symbols. Then third step, express the statement as an English sentence. So those are like the 3 steps that we'll follow every time we're working with a truth statement in words. I think if we symbolize it first and then write it out in words, it's easier. So let's symbolize the given statement. So it says, it is not true that pearls are not found in clams. So the statement is, or the simple statement is that pearls are not found in clams. And what we're doing is we're negating it because we're saying it's not true that. And then here's my statement. Pearls are not found in clams. So P is underlined, right? So we're going to use P to represent pearls are found in clams, right? So since we're saying they're not found in clams, we have to negate P. So that's the statement. Pearls are not found in clams, so not P. But now what we're doing is we're saying it's not true that pearls are not found in clams. So we're negating the given statement. So we're going to have not P. And that's equivalent to P. So now let's write it in words. So the above statement as an English sentence is that pearls are found in clams. So that would be the equivalent statement in English. The next equivalence that we have is the commutative equivalence. Very similar to the commutative property in math, actually, in algebra. So if you remember in math, the commutative property says that if we were going to take 3 plus 2, we can rewrite that as 2 plus 3, right? It's going to give us the same answer. Same thing if I had 3 times 2 or 2 times 3, I'm still going to get the same answer, right? So I just think of it that way. That's what helps me remember that order doesn't matter. So if I had P and Q, that's equivalent to writing Q and P. Order doesn't matter. And then similarly, P or Q is the same thing as saying Q or P. Order doesn't matter. So basically, the order in which the statements occur in a conjunction or in a disjunction is immaterial. So in other words, reordering the statements does not change the truth value of the compound statement. And we could see that here in this table. So this is a truth table for P or Q and Q or P. So here's the different truth values for P and for Q, right? The different truth combinations. And then if we were to look at P or Q, we get true, 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 false. And if we were to look at the truth values of Q or P, it's the same outcome, right? So since the truth values of these two statements are identical, we say that the disjunctions are logically equivalent. So again, whenever we have a disjunction or a conjunction, order doesn't matter. So let's do a couple of examples. So for these practice exercises, let's rewrite using the commutative equivalence. So for number 1, W and not R is equivalent to writing not R and W. For number 2, we have if S then not R or P. So here's my or. So we could, the disjunction, right? So we could write this the other way around. So we could write P or, and now we could write the conditional statement, S implies not R. These two statements are equivalent. And let's look at number 3. So now we just have a verbal representation rather than symbolic, right? So I will order chocolate fudge cake or chocolate cream pie. So let's follow our 3 steps. So first, let's write this verbal or English sentence using symbols. So I will order chocolate fudge cake. We'll use F. And then we have or, so we use the disjunction symbol, chocolate cream pie, and the P is underlined, so we'll use P to represent I will order chocolate cream pie. So the way we would write this is F or P. So now let's apply the commutative equivalence. So the commutative equivalence, remember, just means that if I have a disjunction, I could rewrite it in the opposite order, right? So P or F. And if we were to write that as English in words, we would just say, I will order chocolate cream pie or chocolate fudge cake, right? So either way, they're equivalent, those 2 statements. We also have the associative equivalence, which is similar to the associative property in math when we're, the algebraic version. So for example, if I had, let's say, 3 plus 2 plus 6, I can rewrite that as 3 plus 2 plus 6. So you see how I changed the grouping instead of the 3 plus 2 plus 6. Now I rewrote this as 3 plus, and then I grouped the 2 plus 6. But either way, they're still going to add up to the same thing, right? The result is still 11. So it doesn't matter how we group, right? The 3 plus 2 plus 6, it's still going to add up to the same outcome. So very similar with the associative equivalence in logic. If I had the statement P and Q and R, I can rewrite that as P and then group the Q and R. And it's the same thing with the disjunction. If I had P or Q grouped together and then or R, I could rewrite that as P or and then Q or R. I could have grouped the Q and the R together. So the associative equivalence only pertains to the conjunction and disjunction connectives. It doesn't work like that if we were using the conditional. So both symbols either have to be conjunction or disjunctions. The order of the letters remains unchanged, right? We're not changing the order of anything. All we're doing is regrouping, in other words. The grouping symbol is moved. We're either going to slide it to the left or to the right. So let's practice. So the first one we have, so we're going to rewrite these using the associative equivalence. So we have G or S or not P. So you see how in the group we have S or not P. So now let's just slide the grouping to the left. So let's group G or S. Now we're going to have or not P. Okay, so we just slip the grouping symbols to the left and we group the G and the S together. We'll do one more. So this one we have not A and B and not C. So the not A and B are grouped together and then conjoined, right? The conjunction with not C. So let's just regroup, and now let's just move the grouping symbols, the parentheses to the right, and we'll group the B and the not C. So we would have not A and let's group together the B and not C. So that's another way to rewrite the same expression using the associative equivalence. And then we also have what's called the distributive equivalence. Kind of similar to the distributive property in math. So for example, if we had, let's say, 4 times x plus 3, we distribute the 4, right? So this would be equivalent to 4 times x plus 4 times 3, which is 12. So this is going to be similar in the sense that if we look at the distributive equivalence with the and, so you see how we have P and Q or R. So if we're joining a statement with an or statement, think, okay, I'm going to distribute the P to the Q. So we're going to have P and Q. And then we're going to join it with an R. So it's like we're distributing the end, the P end, over to the Q and to the R. And we're joining it with the union or the disjunction. So we're going to have P and Q, or now distribute the P end to the R. So we're going to have P and R. And it also, works for the disjunction. So I could distribute the P or to the Q. So I'll have P or Q. And then the and becomes the connective. And then now I could distribute the P or to the R, and I'm going to have P or R. So that's how the distributive equivalence works. So think of it as there's 2 forms of the equivalence. One tells us that the conjunction distributes over a disjunction. That was this one, right? The first one. Think about distributing the conjunction. The other one tells us that a disjunction distributes over a conjunction. So now we have a disjunction as the main connector. So we're distributing it over the conjunction. So let's practice this equivalence. So let's look at number 1. We have not B or not S and R. So think about distributing, right, the not B with the disjunction over the conjunction, right? So we're going to have not B or not S and now we're going to have not B or R. So we distributed the disjunction over the conjunction. So we get not B or not S and not B or R. And we'll do another one. So now we have our main connective here is a conjunction. So we're going to distribute that over the disjunction. So we're going to have S and T, or, right, the disjunction. Now distribute the S with the conjunction over to the not R. So or S and not R. And that would be the equivalence. And this last one, we'll do what we were doing for the other ones, the third example. Let's just practice, with an English statement, and then we'll symbolize it, and then we'll translate back to English. So number 3 says, to be accepted at a particular college, a student must have a high GPA and be active in either athletics or student government. So let's symbolize this. So we have 3 different simple statements here. We have a student must have a high GPA, must be active in athletics. So the high GPA will use G, be active in either athletics, which is A, or active in student government, and we'll use S. So to symbolize this, a student, look where the commas are. You see how it says a student must have a high GPA, comma. So that's going to be G. And so we're going to use the conjunction active in either athletics or student government. So this is going to be a disjunction, right? So we're going to join a conjunction with a disjunction, which is A or S, right? So the student must have a high GPA and be active in athletics or student government. So now let's apply the distributive equivalence. What is this statement equivalent to? So the main connective here is the and statement. So that's going to distribute over the or statement. So we're going to have G and A, and then or disjunction, right? G and S. So those two statements are equivalent. And let's translate to an English sentence. So let's look at the left-hand side first. So the left-hand side, we have to be accepted at a particular college, a student must have a high GPA and be active in athletics, right? That's left-hand side. Or now look at the right-hand side. They must have a high GPA and be active in student government. So let's write that. So to be accepted at a particular college, let's look at G and A, right? A student must have a high GPA and be active in athletics. So that's the left-hand side. Now we have the main connective, or a student must have a high GPA and be active in student government. So that's how we would write that compound statement in words. So to be accepted at a particular college, a student must have a high GPA and be active in athletics, or a student must have a high GPA and be active in student government. So before I end this lecture, because we are done with section 1.5, this was just an introduction to these first few equivalences, the double negation, the commutative, the associative, and the distributive equivalences. Section 1.6, you're going to be introduced to more equivalences. These were just the first few, but I want you to know that I did post in, the week 1. I'm sorry, this is week 2. So in the week 2 module, in addition to posting this handout, I also posted, let me just share, I posted equivalences. You should be able to see them now. So I, copied from the book. There's a page in the book where it lists all the equivalences. So it's nice just to have them all in one spot, right? And until you start remembering them, print this. So we did up to here, right? In this lecture, we covered the first 4, the double negation, the commutative, the associative, and the distributive. And they're right here. So again, use this to your advantage, print it, have it handy all the time when you're working on practice problems and when you're watching the videos and working along with me. Because when you could glance at it and you have it in front of you, you're going to start to remember it. And it's not going to be so much memorization anymore just because you're going to know it from using it so much. So I did want to point out that I do have this posted as a PDF in the week 2 module. So just make sure you take a look at this.